Every AI you use depends on a gaming chip. That sounds impossible, but it's completely true. Graphics processors accidentally became the world's smartest computers. Today's AI revolution began with rendering video games. Here's how graphics cards took over artificial intelligence. What makes a GPU completely different from a normal CPU? CPUs solve a few difficult problems extremely quickly. GPUs solve thousands of simpler problems all at once. Modern AI models contain hundreds of billions of mathematical parameters. Training them on CPUs would take years or even decades. GPUs reduce that time to days or sometimes even hours. Without GPUs, ChatGPT and modern AI simply wouldn't exist. Graphics processors became the foundation of today's AI revolution. Inside a CPU, most space is reserved for control logic and cache. This makes CPUs excellent at handling unpredictable software instructions. GPUs take the opposite approach. Almost every transistor becomes a mathematical processing core. Instead of 4 or 8 powerful cores, modern GPUs contain thousands of smaller computing cores. Each core performs identical calculations simultaneously. This massive parallelism creates extraordinary computational power. The same design used for graphics also happens to perfectly fit AI. Artificial intelligence relies almost entirely on matrix multiplication. Every AI neuron multiplies numbers before producing an output. One AI response requires billions of these calculations. GPUs perform them all simultaneously. Modern tensor cores accelerate matrix multiplication even further. High-bandwidth memory continuously feeds data into those cores. Fast memory keeps thousands of processors busy every second. Multiple GPUs connect together using ultra-fast interconnects. Entire AI supercomputers work as one enormous processor. Parallel hardware makes modern artificial intelligence possible. Massive GPU clusters train today's largest language models. Self-driving cars analyze live camera feeds using onboard GPUs. Scientists simulate proteins to accelerate drug discovery. Image and video generation rely entirely on GPU computation. Financial systems analyze enormous datasets within milliseconds. Parallel processing delivers dramatically higher computational performance. Modern GPUs scale from desktop computers to giant AI supercomputers. Software frameworks make thousands of processors appear as one. GPUs became the world's most important computing engine. Running thousands of cores produces enormous heat and power consumption. Limited onboard memory restricts extremely large AI models. Moving data between GPUs can become a major bottleneck. Manufacturing advanced AI chips remains incredibly expensive. Engineers are developing dedicated AI accelerators beyond traditional GPUs. Photonic processors perform calculations using pulses of light. Future supercomputers may combine GPUs with quantum processors. Gaming hardware unexpectedly became the engine powering artificial intelligence. Subscribe to Node 01 as we continue decoding the technology shaping our future.